So square close packing has two types. One is centered square close packing and the second is primitive square close packing. And this is the difference between them, right? Now in both centered square close packing and primitive square close packing, the atoms arrangement is of A type, right? In both centered and primitive square close packing, the atoms arrangement arranged in A type, right? Now A type is the arrangement of the atoms. Now here is the centered square close packing and primitive square close packing. The number of atoms taking part to form these type of packings is number of atoms in centered square close packing is equal to the 4 atoms are participate and 1/4 part of one atom participate, right? So 1/4 of 4 atoms, that means 1 atom. So 1 atom participate to form the centered square close packing. Now come to the primitive square close packing. In primitive square close packing, you may observe from corners 1/4 part, right? From corners 4 multiplied 1/4 is equal to 1 atom and 1 atom at the center. So at center 1 atom. So total 2 atoms. So that means to form the primitive square close packing, 2 atoms have been used. 2 atoms participates, right? Now surface area of atoms participating in centered square close packing and primitive square close packing atoms. So surface area here is the space less. So let me write it here. Let me write here. We will discuss this hexagonal later on, right? First complete this one, the centered square and primitive square. So here is the number of atoms. Here the area of atoms in centered square and here is the primitive square. Right? So at centered square the area 1 atom is there, 1 atom. So surface area is pi r square because the atom is rounded, right? Spherical shape. So spherical means pi r square will be there. Now here is the 2 atoms. That means 2 into pi r square. That is 2 pi r square. Right? So this is the surface area of the atoms in centered square planar and primitive square. Now move to the coordination number. The coordination number is centered square close packing is, you may observe easily here that 1 atom is touching with the 4 atoms. 2 atoms of same layer, 1 atom is of upper layer and 1 atom from the lower layer. So 4 atom touching to the 1 atom. So coordination number of centered square close packing is 4. So this the coordination number is equal to 4. And this has the coordination number. Coordination number. In this also, two edges of the same layer, one above, one below. So in this also the coordination number is 4. The coordination number plays a major role in the questions because question generally comes over the coordination number, right? The coordination number plays a major role in the questions because question generally comes about the coordination number. So here the coordination number in centered square close packing is 4 and the coordination number in primitive square close packing is also 4. Now area of unit cell. Area of unit cell. Now area of unit cell is in centered square, and in primitive square. So at centered square, if you are going to observe here the area of unit cell, it is a square. A square has the unit cell edge length. If you are going to calculate here the edge length, then the edge is just like this. The one atom, second atom, here the third atom, here the fourth atom. So this is the square. If you are going to observe here, this edge length, edge is 2r, r plus r, 2r. So the area of unit cell is equal to, so area of unit cell is equal to r square, edge length square, a square. So area of square is equal to the a square. A is equal to 2r here, r plus r, 2r. So it is a is equal to 2r, so 2r square, that is 4r square, where r is the radius of the atoms or particles, right? Whether it may be atoms or ions. So r is the radius of the particle. R is the radius of particle. And a is the edge length of square. Right? Now come to the primitive square. So primitive square is this. If you are going to see, this is interesting. I am going to make it here. So this is the structure. If you are going to see here, this and this. So in this, the edge, this is the edge, right? Edge length. If you are going to combine this, the vertex, this is like this triangle, right? Here, this is r plus r plus r plus r. This is 4r, right? This is r, here r. This is 2r, here is also r. So it is 4r. So 4r, you have to calculate this one, edge length. This is a, this is a. So here, if you are going to see, this is a, this is a, this will be root 2a. So 4r is equal to root 2a, right? And Pythagoras, a root 2a, Pythagoras, because 90 degree angle in square. So here a will be, so a is equal to 2 root 2 r. So the area of a square is equal to 2 root 2 r square 2 root 2r square, that will be equal to 8r square, right? So this is the area of square of primitive square closed packing structure, two-dimensional, right? So this is the all about square closed packing, the coordination number, the number of atoms, the area of atoms, and the area of square, right? And also with the primitive square closed packing, coordination number here, number of atoms here, right? Number of atoms and the square of the square area, right? So this, now one more thing in this that is remaining, that is the voids, about the voids, right? If you are observe here, the voids is of square type. This. Void is actually the empty space between the particles, right? So here the empty space is this. If you are going to observe, this is just like this, and this is the void, right? So it is square type. This is type square type, just like, right? So it is square planar void, square planar void, right? So this is all about the void. Now everything about the two-dimensional square closed packing has been finished. Now come to the two-dimensional hexagonal closed packing structure.